Going beyond the familiar solar system, we set foot in the world of exoplanets, planets wandering in the vast ocean of space. Since the first exoplanet was confirmed in 1992, our journey of discovery has reaped countless achievements, opening the door to new horizons. Thousands of exoplanets have been discovered, overwhelming us with their unimaginable diversity and richness. Are there second Earths among them, places that nurture life like our green planet? Expeditions to find exoplanets are accelerating and will not stop. How is an exoplanet defined? What methods do scientists use to detect them? Don't forget to leave a like and subscribe to the channel to support those who brought you this video. Please share your thoughts and questions about exoplanets in the comment section below. Exoplanets are planets orbiting stars other than our Sun and existing outside the solar system. They reveal vast and unexplored regions of space. Before the 1990s, humans had never observed any planets outside the solar system, making their existence mysterious and impossible to confirm. However, over the past 3 decades, NASA's exoplanet catalog has grown significantly. As of 2023, the catalog lists more than 5,500 confirmed exoplanets, along with nearly 10,000 other exoplanet candidates. These exoplanets typically orbit in what is known as the habitable zone, a region around the star where conditions are not too hot or too cold, allowing the existence of liquid water, which is essential for life as we know it. This makes them prime targets in the search for extraterrestrial life. A few centuries ago, the concept of extrasolar planets was just speculation. Many astronomers predict their existence, but no one can confirm their exact number or whether they resemble planets in our solar system. Developments in observational technology and space research have opened new doors, helping us gradually better understand these distant worlds and the endless potential of the vast universe in which we live. This progress not only sheds light on the mysteries of the universe, but also suggests new possibilities for finding and understanding extraterrestrial life, opening a new chapter in the history of human discovery. In 1992, a historic milestone was set with the discovery of planets outside the solar system. At that time, astronomers officially confirmed 2 planets orbiting the star PSR 257+12 in the Virgo constellation. In 1994, a 3rd planet orbiting this star was also discovered. To date, planet PSR 1257+12a, the closest planet to the parent star in the system, still holds the record as the smallest extrasolar planet discovered, with only half the mass of the Moon. Recently, several reports have documented wandering planets. They are planet-sized objects but do not orbit any stars. Therefore, they are not accepted as planets by the International Astronomical Council. These objects may have been ejected from their planetary systems, or they may have formed without the gravitational influence of any stars. And people call them rogue planets, wandering planets, or orphan planets. After the first exoplanet was discovered in the 1990s, the discovery of exoplanets remained stagnant. It wasn't until 2009 that the hunt for worlds in outer space really began to explode with the appearance of the Kepler Space Telescope. The telescope was named in honor of German astronomer Johannes Kepler and was launched on March 7, 2009. Initially, the expected operating time was 3.55 years, but Kepler worked persistently for over 9 years. Kepler opened our eyes to the diversity of planets that exist in the galaxy. Analysis of Kepler's discoveries concluded that 20 to 50% of stars visible in the night sky may have small, possibly rocky, planets similar in size to Earth and located in the habitability of their parent stars. That means they lie far away from their parent stars, where liquid water, a vital ingredient for life as we know it, can collect on the planet's surface. Observing so many stars has allowed scientists to better understand stellar behavior and properties, which is important information in studying the planets that orbit them. New research on stars using Kepler data is also advancing other areas of astronomy, such as the history of our Milky Way galaxy and the early stages of exploding stars called supernova, which are used to study the expansion rate of the universe. Before retiring the spacecraft on October 30th, 2018, scientists unleashed Kepler's full potential, successfully completing multiple observation campaigns and downloading valuable scientific data even after initial warnings of low fuel levels. After 9 years of collecting data in deep space, showing that our night sky is filled with billions of hidden planets, even more planets than stars, NASA's Kepler Space Telescope has run out of fuel and necessary materials for further scientific activities. In October 2018, NASA decided to retire the spacecraft in a safe orbit away from Earth. Kepler leaves behind a legacy of more than 20,600 planetary discoveries from beyond our solar system, many of which could be promising sites for life. Soon after, the transit satellite TESS took to the sky in April 2018 on a SpaceX Falcon 9 rocket with a mission to catalog thousands of exoplanet candidates. TESS is tasked with surveying more than 200,000 of the brightest stars near the Sun and searching for exoplanets, including those that could harbor life. In addition, NASA has also added a series of other famous space telescopes, such as Spectre RG, Hubble, and most recently, James Webb. With the presence of modern telescopes, many exoplanets have been added to NASA's data warehouse. As of now, there have been 5,011 confirmed exoplanets, and several more are still waiting to be confirmed. To detect exoplanets, scientists use telescopes to measure the star's brightness, gravity, or motion. From there, they calculated the presence of exoplanets. There are 5 most popular methods that help scientists search for exoplanets. First, the radial velocity method in astronomy, also known as the ray velocity method. This is a method of determining the gravitational interaction between a planet and a star. Imagine this method as a tug-of-war between one side, the planet, and the other, the star. We know who won this game, the stars. That's why planets orbit stars, not vice versa. But even though the planet is small, it still has gravity. It still has an effect on its host star, even if that effect is much less pronounced than the star's effect on the planet. As you can imagine, the larger the planet, the greater its impact on its star. Small planets like Earth cause their stars to wobble just a little. Larger planets like Jupiter have a much stronger impact. The wobble of a star can tell us whether a star has planets, how many planets there are, and how big they are. Wiggle stars are useful for finding exoplanets. But how do we see wiggle stars? The method used is called Doppler shift. It is named after the physicist who discovered it about 150 years ago. You may not know it, but you've probably experienced the Doppler effect before. Have you ever noticed that the sound of an ambulance passing you on the road increases in intensity as it approaches you, and then gradually decreases as it drives away? The reason is because when an object emitting energy, like an ambulance speaker, moves closer to you, the waves will accumulate and press against each other. And when the object moves away, the wave expands. The radial velocity method was one of the first successful methods for finding exoplanets and continues to be one of the most effective. Many astronomers and telescopes around the world use this method to discover exoplanets. But 2 notable observatories where this work is done are the Keck Telescope in Hawaii and the La Silla Planetarium in Chile. Second, the transit method, similar to the way a solar eclipse occurs, is an interesting event that people often witness. It occurs when a planet passes directly between the host star and the telescope. The planet will block some of that star's light for a short period of time. The planet's subsequent transit of the star will cause it to become slightly dimmer, which is a very small change, but enough to alert astronomers to the presence of an exoplanet. The transit method not only detects planets, but also provides parameters about the planet's atmosphere and temperature when transiting through the star. NASA's Kepler mission, which hunted for planets by transit from 2009 to 2013, found thousands of possible exoplanet discoveries and provided astronomers with valuable information about the distribution of exoplanets in the galaxy. Up to now, this is the most successful method for scientists. It has found nearly 4,000 exoplanets out of the total number of confirmed planets. Third, according to the imaging method, Usually planets that are very far away from our Earth are millions of times fainter than their host star. Therefore, taking pictures of exoplanets is a very difficult task. A major problem that scientists encounter in this search method is that they have to deal with the enormous brightness of the host star, which obscures the images of exoplanets. Any light reflecting off the planet or radiating heat from the planet itself is drowned out by the enormous amount of radiation coming from its host star. It's like trying to find a flea in a light bulb or a firefly flying around a headlight. Direct imaging is still in its early stages as a method for finding exoplanets, but there are hopes that it will eventually be the primary tool for finding and characterizing exoplanets. Future live imagers could image exoplanets, allowing us to determine atmospheric, oceanic, and land patterns. Fourth, the differential gravity method. This is a method of analyzing how light from a distant star is bent and focused by gravity when a planet passes between the star and a telescope observed from Earth. Among many of his insights, Albert Einstein reconsidered the concept of gravity, defining it less as a mysterious attraction between objects than as a geometric attribute without time. In other words, large objects warp the fabric of space. This effect causes light to distort and change direction when it is affected by the gravity of a massive object, such as a star or a planet. When using differential gravity, scientists measure light from a distant star or from a quasar. When light passes through the star system to be searched, it will be bent by the gravity of the star and the planet orbiting it. Based on the degree of light bending, scientists can calculate quite accurately the size of that planetary system. With this method, scientists have found about 90 distant exoplanets. The fifth astrological method is a method based on a planet's orbit that can cause a star to wobble in space relative to nearby stars. First, let's return to the radial velocity method for an explanation of how planets cause their stars to wobble through space. We will wait. Okay, let's go back, okay? Doppler shifts aren't the only way astronomers can find stars wobbling due to the gravity of their planets. Wobbles can also be seen when there is a change in the star's apparent position in the sky. In other words, scientists can actually detect the position of the pulsating star in space. Astrometry, as the method is called, remains extremely difficult to perform. Stars oscillate at such small distances that it is difficult to accurately detect wobbles from planets, especially small planets the size of Earth. To track the movements of these stars, scientists take a series of images of a star and several other stars near it in the sky. In each image, they compared the distance between these reference stars and the star they were testing for exoplanets. If the target star has moved relative to other stars, astronomers can analyze that movement for signs of exoplanets. Astrometry requires extremely precise optics and is especially difficult to do from Earth's surface because our atmosphere distorts and bends light. "We wanted to send a message in a bottle in the ocean of space," said Jonathan Jiang, an astrophysicist at NASA's Jet Propulsion Laboratory, JPL, in California. The message designed by Jiang and his team builds on previous missions humans have sent into space. In fact, the researchers timed the creation of the new message to the 50th anniversary of the Arecibo message, the first attempt by a high power to contact extraterrestrials. The 1974 message used binary code and conveyed information about humanity's base 10 numbering system, common vital elements, and a map of the solar system. The new message also encodes information in binary form and describes the basic mathematics, physics, and biology that aliens need to understand humans, including descriptions of DNA, amino acids, and glucose. It also contains maps of the Milky Way, the solar system, and Earth itself, including information about the planet's makeup and atmosphere. Jiang and his team used globular star clusters in the Milky Way as landmarks on their proposed map. These globular star clusters are bright and easy to see, and they have enough distinguishing characteristics that they can act as useful signposts. But how do you convey this new message to an alien civilization? The answer lies in the hydrogen atom, says message co-designer Chi Tianjin of Hanze University of Applied Sciences in the Netherlands. Neutral hydrogen found in interstellar gas can enter a high-energy state after collisions with other atoms or electrons. After about 10 million years, one of these high-energy hydrogens undergoes a transition back to a lower-energy state, an event known as a spin-flip transition. This rotational transition provides a convenient common unit of time for communication in the period after the Big Bang in which the message was sent. It would be possible to send multiple messages with timestamps and updated information. So an alien civilization could theoretically learn more about Earth over time, Jin added. The search for extraterrestrial intelligence, SETI, can be divided into two approaches, passive and active. In passive SETI, scientists use giant telescopes to listen for or look for signs that intelligent life is out there. Such hints may include radio waves sent either accidentally or intentionally by an alien civilization. SETI proactively involves sending signals. These efforts are less common, and most to date have been largely symbolic. In 1972 and 1973, the Pioneer spacecraft was launched with a pair of plaques depicting the drawings of a man and a woman, and symbols intended to represent the origins of the craft. The arrays are humanity's first messages designed to travel outside the solar system, but the chances of them being found in the vastness of space are slim. Sending information about our location into space is causing controversy. Some experts warn that revealing our exact location in the galaxy could harm the world itself. Should we support alien search efforts by listening, or should we not proactively reach out? If aliens discover Earth, they are more likely to want to invade and colonize our planet than befriend it. If you look at history, contact between humans and less intelligent creatures has often been disastrous, and the encounter between technologically advanced civilizations and primitives has gone badly for less advanced creatures. Revealing our location information to someone is a double-edged sword because, after all, we don't know who the aliens are, what their ethical behavior is, and what their plans are. But if they have technology far superior to ours, their ambitions will not be small. When they stand before a green planet rich in resources, food, beautiful scenery, and a thriving civilization, who knows they won't be greedy? In your opinion, so what? Do you support sending information about our planet into space? Please leave your opinion below in the comments section to share with everyone. We now live in a universe of exoplanets. The number of confirmed planets is in the thousands and growing. That's just a small sample of the entire galaxy. This number could grow to tens of thousands within a decade as we increase the number and observing power of robotic telescopes sent into space. Any rash decision will come at a high cost, and a conversation is needed above all for the safety of the Earth, which comes first. Discovering aliens, talking to them, and participating in technological and cultural exchanges can raise human civilization to a new level. But it can also wipe out everything people have worked hard to build. So be careful with your messages. Thank you very much for listening and supporting Space 30 Minutes. Today's video also ends here. However, please join us in continuing our journey to explore the universe and decode these amazing mysteries in the next videos. I wish everyone a good day with family.